Okay, so taking a couple examples here from the quadratic formula, I pulled number 18 out of the book, and it is 6x minus 5 equals negative x squared. Well, in order to use quadratic formula, of course, we need to have it in standard form so we can come up with the a, b, and c values. So what I've done is I've gone ahead and done my inverse operations to get it equal to 0, which is the standard form. So here we are with the standard form. And my a is going to be 1, my b is going to be 6, and my c is going to be negative 5. So as I look, let's see here why this is going. So the c is negative 5, so I've gone and populated in my quadratic formula. And as I have negative 6 plus or minus square root of 6 squared minus 4 times 1 times, let's see here, throw in the negative 5, and let's see here. And then we did some math operations here, and I got negative 6 plus or minus the square root of 36 plus 20 over 2 times 1, and that simplifies to negative 6 plus or minus square root of 4 times 14 over 2. Doing some simplification here, what I've done there is split up my denominator, and then I've gone ahead and rewritten it in simplest form, negative 3 plus the square root of 14 or negative 3 minus the square root of 14. Okay, so more examples here that I pulled out of the book. Number 26. In order to solve this, we are going to just evaluate the discriminant and determine the number of real solutions. So that's based on the value of our discriminant, which we covered in our notes. So my discriminant is b squared minus 4ac. Have to get my equation into standard form in order to find out what a, b, and c are. So my b is negative 4 squared minus 4 times a, or 4 times negative 4 times 1 times negative 5. So I get 16 plus 20, and that is going to equal 36. And since 36 is greater than 1, I'm going to have 2 real solutions, because the square root of 36 would be a positive or a negative 6. So that gives me my 2 real solutions. Looking at number 35, it's not in standard form, so I need to get it put into standard form first. So I've gone and done my inverse operations, and I'm going to rewrite it in standard form here. So I have 3x squared plus x plus 2 equals 0, giving a is 3, b is 1, c is 2. And when I go ahead and populate that discriminant, I have 1 squared minus 4 times 3 times 2, which is going to give me 1 minus 24, which is going to give me a negative 23. Negative 23 is less than 0. And if I'm thinking about, well, my discriminant tells me that I have no real solutions. And think about what we know. Can we find the square root of a negative number now? No. So that's why we have no real solutions, because it's not going to happen. Put it in a calculator to give you error. And then if we go over here to number 32, let's see here, x squared minus 12x plus 36 equals 0. A is 1, b is 12. Actually, b is negative 12, and c is 36. So filling in my discriminant, negative 12 squared minus 4 times 1 times 36 ends up giving me 144 minus 144. And that is going to come to 0, and 0, the square root of 0 is 0, so that is one solution. So when my discriminant equals 0, I have one real solution. And then just going back and understanding real quick, the discriminant is going to be b squared minus 4ac. You have to make sure that your equation is in standard form in order to find your a, your b, and your c values. Then we substitute in a, b, and c into our discriminant, solve, and if we have a positive number greater than 0, it is 2 real solutions. If we have a negative number, then it is less than 0, so we have 0 real solutions because we are unable at this time to find the square root of a negative number. And then if it is equal to 0, then it has 1 solution because 0 is neither positive nor negative, so the square root of 0 is 0. And that is evaluating using your discriminant.